Hi, I'm Shanoj. In this session, let's look at how a data lake can help you streamline data management. We will focus the general concept and specific AWS product that can help you build a data lake. Actually, what exactly is a data lake and how it is differ from a data warehouse? Friends, there are several differences between a data lake and a data warehouse, especially in data structure, the ideal users, processing methods, and the overall purpose of the data are the key differentiations. Data structure in data lake will be in raw. On other hand, it will be in processed in data warehouse. Purpose of data not determined in data lake, but in data warehouse. Currently, it is in use. Users for data lakes are data scientists, and in data warehouse, it is business professionals. Accessibility in data lake is highly accessible and quick to update. On the other hand, data warehouse will be more complicated and costly to make changes. This is another overview from Talent. A data lake is a vast pool of data, the purpose for which is not yet defined. A data warehouse is a repository for structured, filtered data that has already been processed for a specific purpose. A data warehouse is a central repository for structured and well understood problems. Users use SQL, business intelligence tool, and other tools to interact with data in a data warehouse. On the other hand, a data lake is a place to store your raw data, for which the business value is not yet discovered. Data lakes are very flexible and users are free to transform and structure the data to their needs. Here is another view from AWS. A data lake is a centralized repository that allows you to migrate and store all structured and unstructured data at unlimited scale. Yes, in unlimited scale. A data lake is a single platform that combines storage, data governance, and data analytics. Let's spend some time to take a brief look at various services that can help you in building a data lake in AWS. Okay, let's start with storage options. A data lake architecture in AWS use S3, Simple Storage Service, as a cost-effective solution. Then why we are using S3? Why we built a data lake on Amazon S3? Because Amazon S3 is designed for 11 nines of data durability. That means 99.999999% of data durability. With that level of durability, you can expect that if you store around 10 million objects in Amazon S3, you should only expect to lose a single object every 10,000 years. Amazing, right? So that's a capability here. That's a durability. The service automatically creates and store copies of all uploaded S3 objects across multiple systems. This means your data is available when needed and protected against failures, errors, and threat. Amazon Glacier is suitable for data backup and long-term archival at the low cost and has the same 11 nines of durability. These all are the two services that are primarily used for data lake storage. Okay. Now, next challenge is how to consolidate data in a data lake, right? Let's look at different data sources and options. For collecting data for real-time streaming, we can use data firehose. With firehose, you can reliably capture, transform, and load streaming data to various AWS data stores. For example, you can continuously store streaming data in S3, in Redshift and Splunk, and you can use every existing BI tools for real-time analytics of data streaming. For continuous loading of data generated on-premise, you can use a storage gateway. AWS Storage Gateway is a hybrid cloud storage service. It extends X3 to your on-premise data center, and Storage Gateway can present an S3 bucket as a file share to your on-premise data processing system. How it works? For example, a file that is added or modified in the file share is stored automatically in S3. Storage Gateway has 3 different modes. Your on-premise system can use a storage gateway. One like a file share, like a block storage, or even as a virtual tape device for data migration. We are talking in the order of petabytes and exabytes. So AWS provide 2 other options. One option is Snowball. Snowball is a physical appliance that you can use to copy your on-premise data and ship it back to AWS. Snowball is a tamper-resistant appliance. This solution is cost effective for petabyte scale transfers. Once it arrives at AWS, data is transferred to your S3 bucket. Another option is Snowmobile. Similarly, Snowmobile extends this concept to a 45-foot long shipping container for exabyte scale data migration to cloud. Now, these are not the only way to ingest data as AWS Cloud considered, because AWS Cloud is API driven. So you can use SDKs, command line tools, and other n numbers of third-party tools to store your data in the S3 data lake. So far we discussed the storage and the ways to ingest and migrate data to data lake to make the data usable and discoverable for the users. Now we need to provide some metadata, right? So data catalog has the metadata about the raw data in the data lake. This metadata creation is not one-time activity actually. It's required ongoing monitoring of new data assets as well as tracking versions that were created by data transformation and processing. Now, if you store just the raw data without any means of discovering and using the data lake become a data swarm. So what is data swarm? A data swarm is a deteriorated and unmanaged data lake that is either inaccessible to its intended users or is provided little value. And data catalog provides a queryable interface for all assets stored in the data lake. Data lake's S3 bucket. Basically, S3 bucket is a storage. So it becomes very important when you have a data lake to have a metadata in some form of data catalog. Basically, there are two ways in which we can approach this. We can write the logic to collect the metadata, and this approach is referred as a comprehensive data catalog in the AWS white paper. Here, you are responsible for collecting and maintaining the catalog. One approach for implementing this is by using service like Lambda. When objects are added or modified in the S3, it can trigger the Lambda function, right? So, which in turn collects metadata from the object and upload to queryable systems. It can be DynamoDB, Elasticsearch, and application will become available queryable form in the DynamoDB, and the Elasticsearch to discover the data available in your data lake. Hope you got, right? So AWS Glue is another option. Like AWS Glue is a managed option for building and maintaining the data catalog. So it is a managed option. AWS Glue can automatically build a catalog for data store in S3 or DynamoDB and any other database that supports JDBC connectivity. AWS Glue will call the configured data source, discover the metadata, which is basically table definitions and schema, and stores them in Glue data catalog. Once it catalog, your data in the data lake is immediately searchable, queryable, and available for other downstream processings. So there are multiple ways to transform the data. Here are some of common approaches you can use a Hadoop cluster. Okay. So in Amazon EMR is a fully managed Hadoop cluster that you can efficiently run and scale Apache Spark, Hive, and other big data frameworks. Also, you can load your S3 data to EMR Hive tables and then return them back in Paraquet format or any other format. Another approach is load data from S3 to Apache Spark and then transform the data to Paraquet. A simpler data transformation option is to use Glue ETL. We already discussed Glue ETL. So AWS Glue automatically generate the code to extract and transform and load your data. You need to simply point Glue to a data source and the target, and the Glue service will create the ETL scripts to do the transformation. The code can be generated in Scala or in Python. It runs on Apache Spark. The nice thing with this approach is that the Glue ETL framework will provision the required resources, run the job, and then terminate the resource. So it's kind of managed, right? It's managed service, so it will take care of that part. So Kinesis Firehose has support for a streaming data transformation and support conversion to formats like paraquets or ORC before sending into data stores. Firehose can also keep a backup of the original data in S3. It's a native service, so it has those capabilities. So this concludes a generic but a detailed overview of AWS Data Lake. Hope you all enjoyed the video. Thanks for watching.